The buttery physics of falling toast, unraveling the mystery, the great butter paradox. Let's all take a moment to remember the last time we reached for a slice of toast. You were in a hurry, right? One slip, one tragic moment of gravity, and splat. Your breakfast hits the floor. Butter side down. Cue the dramatic sigh. But what if I told you that this everyday disaster isn't just bad luck? What if it's physics, fate, and a very British obsession with breakfast colliding? Welcome to the quirky world of the falling toast theorem. A question so deceptively simple it's puzzled scientists. Stood in for Douglas Adams and anyone who's ever mopped up a buttery mess. In this episode, we'll walk you through a hypothetical research exploration podcast episode that dives into the sticky question, why does toast always land butter side down? Buckle up. We're mixing butter, bread, and brain power. A history of buttered complaints. The buttered toast phenomenon isn't just a modern kitchen gripe. It's a pop culture punchline and a scientific mystery wrapped in a carb. For decades, folks have joked that gravity has a vendetta against breakfast foods. Even Monty Python got in on the act, with Terry Jones' character ranting about the injustice of the situation in the film Monty Python and the Holy Grail. But it's not just comedic fodder. The question gained scientific traction in the 1990s when physicist Robert Matthews, inspired by a breakfast mishap, started wondering, is there a real reason toast behaves this way? Or is it just confirmation bias? Matthews argued that the height of a standard table, about 30 inches, means toast tumbles just enough to complete a half rotation before hitting the ground, but never a full one. In other words, gravity gives it a nudge, but the height of the table is the real villain, or hero, depending on your breakfast preferences. But then there's the butter, right? The greasy gold that makes the disaster definitive. Is butter just the punchline, or does it play a role in the physics? Let's dig in. The physics of a falling slice. Imagine a piece of toast perched on a table. It's balanced, delicious, and doomed. The moment it slips, a chain reaction begins. Number one is the initial drop and tumbling. When the toast slides off a surface, it rotates mid-air due to the torque created by its center of mass. Think of it like a diver doing a flip. Once it starts rotating, it keeps going until something stops it. The critical factor here is the height of the drop. If toast falls from a greater height, say off a counter or a shelf, it has time to complete a full 360-degree flip. But on a standard table, it only manages about 180 degrees, landing precisely on the side that just happens to face down and is buttered. Number two, the role of air resistance. Here's where things get tasty. Unlike a solid block, toast is flat and uneven. Air resistance isn't constant. It creates rotational inertia. The buttered side, being heavier due to its butter, adds mass imbalance, which nudges the rotation just enough to tip the scale. Quite literally, Number 3, the sticky butter paradox. Now, butter itself isn't just a flavor booster, it's a friction modifier. A buttered side hitting the floor has more surface tension and is less likely to rebound. Unbuttered toast might bounce or slide, but buttered toast sticks to the ground like it's signed a lease. This making the down side of the buttered toast feel more final. It's not just a crash, just a ceremonial landing. So, is butter the cause? Not exactly, but it implies the effect. Without butter, the toast would still rotate, but we might not notice as clearly because the landing is less sticky. Experiments in the lab and on the stove. The toast question isn't just theoretical. Researchers have actually dedicated time and butter to testing it. The 2006 University of Birmingham study, led by Dr. Chris Garrett, this experiment used a mechanical toast dropper to release hundreds of buttered and unbuttered slices from varying heights. The results: from a standard table height, about 25 to 30 inches, 13 out of 15 buttered slices landed butter side down. But from a 10-foot drop, the proportion evened out. The Jackson and Pergram equation. In 1994, physicists Anthony Jackson and John Pergram developed the universal law of cats and toast, which humorously posits that if you attach a piece of toast to a cat's back, butter side down, the two conflicting forces would lead to equilibrium, hovering mid-air. While this is, of course, a jest, it highlights the absurdity and real-world gravity of the issue, pun intended. Home experiments. Spoiler, it's not scientific, but it's fun. On the Research Explorations podcast, we'd invite listeners to try their own experiments, grab a plate, some bread, and safely buttered slices, but from different heights, and observe the goal: to see how physics and butter conspire to make breakfast our enemy. The bigger picture, why this matters. You might be thinking this is one of the most trivial topics to waste time on, and you're right, it is trivial, but that's exactly why it's valuable. Number 1 is science is mundane. The falling toast question is a gateway to understanding physics in our daily lives. It's not just about bread, it's about how initial conditions, table height, butter weight, influence outcomes, a concept central to chaos theory. Number 2, the roll observation. Confirming bias loves a good buttery landing. We notice when it lands down, but we ignore the times it lands up. Scientists study this all the time, how human perception filters reality. Number 3, applied physics, sort of. Understanding rotational motion and surface tension has real-world applications in robotics, packaging, and even space engineering. For example, how do you prevent a camera from tumbling in orbit? Physics. But Robert, what about podcast Q&A segment? On our imaginary podcast, we close with a lively question and answer, tackling listener questions like, what if my toast is gluten-free? Answer, weirder things have happened. The mass imbalance remains, so physics holds. Does toasting the bread affect it? Answer, lighter toast, maybe less rotational force, but butter still steals the show. What about crumpets or bagels? Answer, science is a buffet. The principles apply, but the math gets messier. Conclusion, embrace the mess, or invent a new kind of table. So, does toast always land butter side down? Not always. But in a world of standard tables and gravitivity's cruel choreography, it's more likely. And if you've learned anything from this post, let it be this. Number one, never underestimate the power of butter as a physics catalyst. Number two, your kitchen is a lab for chaos theory. Number three, sometimes the weirdest questions lead to the coolest discoveries. Next time your breakfast plummets to its greasy fate, remember, you just witnessed a 300-episode worthy collision of gravity, torque, and society's obsession with carbs. And who knows, maybe one day someone will invent a table that launches toast butter side up. Until then, we'll keep buttering, dropping, and wondering. If you enjoyed this episode, imagine how addictive a full research explorations podcast would be, complete with sound effects of splat interviews with buttered toast researchers and a lighthearted debate on whether the universe is out to get breakfast foods. Tune in or just grab a paper towel.